Today's lesson is on arithmetic series. If you recall, the last lesson we did was on arithmetic sequences. So what we're going to do now is we're going to look at those sequences and what happens when we start adding all the terms of the sequence. That's what makes it a series. All right, so once again, we got a nice little formula here, and you're really going to love this because we can use our calculator as well to do a lot of these problems. So let's take our formula here, and remember guys, when you're doing your homework, if you will write this formula down just a few times, you will remember it, but it will also be given to you on the formula sheet when you take your SOL tests next month. All right, so let's see what we got here. Find the sum of the sequence 3, 8, 13, 18, and so on. And look, this is a finite sequence. This is a finite sequence. Why? Because I can see that it does have a last term. It has a last term. If it didn't, we would see this, and then we would know it was an infinite sequence. So let's look and see what we need here. We need to know what the constant difference is, and we can see that that is going to be 5. So our D is 5. The first term, A sub 1 is 3. A sub n, let me erase this just so we don't have any confusion. A sub n is the last term in this sequence, 1, 2, 3, 4, 5, 6, 7, 8. So this is actually A sub 8, and it is 38. N is 8. So what we have here is we're going to plug into our formula now. So we've got the sum of the first, well, not the first 8, there are only 8. So we have n over 2, so 8 over 2 times the first term, which is 3, plus the last term, which is 38, and that's all we got to do right here is simplify all this. So we've got 4 times 41, which gives us 164. So as simple as that, that's how we're going to find the sum of this sequence by using our nice little formula right here. All right, so the sum of these 8 terms is 164. We'll fill that in right there. All right, let's take another one. Given the sum, oh, this is different. This time I have the sum. I have the sum, and what I got to figure out is how many terms. How many terms are in this series? So let's figure out what D is. D is going to be 3, right? 7 minus 4 is 3. 10 minus 7 is 3. First term is 4. The last term, A sub n, we don't know what the last term is because we don't know how many terms there are. So let's set up our formula. We know that, let's go back up here and look. We know that the sum of the n terms is n over 2. N over 2 times the first term plus the last term. We know the sum, so let's just plug in what we know. We know the sum is 175. So that's n over 2. The first term, we do know the first term, it's 4. And why don't we do this? Why don't we figure out what the rule is for A sub n, and then we can plug that in. So let's come over here to the side. Remember, the rule for A sub n is A sub 1 plus D, we know D is 3, times n minus 1. So when we do this, guys, and we plug A sub n in right over here, that's going to get rid of the second unknown that we have in this equation. So let's simplify this. We got 4 plus 3n minus 3. So A sub n is 3n plus 1. So we're going to put that, let me do this. We'll highlight this, 3n plus 1. So we're going to put that right here, 3n plus 1. All right, now as you can see, we've only got one unknown in this equation, so we're going to be able to solve it. So let's go ahead and multiply both sides by 2. Get rid of that 2 over here. So that 2 will get rid of that one, and this gives us 350, right? 350 equals 4n. Hold on just a second. I'm going to actually simplify or combine my like terms in the parentheses here. So now I've got n times 3n plus 5. That should make that easier. All right, so now we have 3 50 equals 3n squared plus 5n. So what do we got, guys? We got a quadratic. We got a quadratic equation, right? So what are we going to do? We're going to subtract the 350 from both sides, get this equal to 0, and see if we can factor this thing. Minus 350. Factoring. Okay, I know I got to have a 3n here and an n here. Let me think of the factors of 350. 35 and 10 are the first two that come to mind. So how about if I put 35 here, 10 here? That's going to be 30 and 35. I think that'll do it. So that one needs to be positive. This one needs to be negative. So if I solve this, remember, using the zero product property, I know 3n plus 35 equals 0, or n minus 10 equals 0. Well, I know this one is not going to give me a good solution. Why? Because n will be negative when I solve this. I know I can't have a negative number of terms, so I'm not going to worry about that. So what I know is that n has to equal 10. So that means this series has 10 terms in it, and when I add up those 10 terms, the sum is 175. All right. Here's one. You should probably pause and try to work this one out. See what you come up with. You are to design a new auditorium for the school. Mr. Yost. Oh boy, that was a while ago. I need to update my problems, don't I? Dr. Poole wants 25 seats in the front row. So let's figure out, that would be A sub 1, right? A sub 1 is 25. 25 seats in the first row, with each successive row having one more seat. So that means D. So this tells me right here, one more seat. That tells me that D is 1. There is space for 32 rows. So that means N is 32. And write an explicit rule for the number of seats in the nth row. So let's see what I want to do here. Explicit rule. So I know A sub n is the first term, or the number of seats in the first row, plus D. D is 1 times n minus 1. So let's simplify that. I got 25 plus n minus 1. Therefore, A sub n, our explicit rule, is n plus 24, right? So that's what we're doing here in part A. In part B, it says, suppose we got a class at Woodson that has 35 students. We want them to go to the performance, but we want them all to sit together so we can keep an eye on them. We want them all in the same row. So what is the first row? Now remember, guys, we know that the first row has 25 seats in it. The second row has 26 seats in it. The third row has 27, and so forth. So without having to go through there and find the number in each row, I want to figure out, I know that A sub n is 35, right? A sub n is 35. All right, and so all I got to do is plug that in, plug that 35 in right there. So 35 equals n plus 24. Therefore, 35 minus 24 is n. So that tells me I got to go up to the 11th row before I'll have enough seats for that class to all sit together. All right, what I want to do now is come back up here to this very first problem, and I want to use it to show you how to use your calculator to do this kind of problem, finding the sum of a sequence. Should have had mine opened up already. I'll pause while it opens. All right, so we're looking at the very top sequence on this page that has the terms 3, 8, 13, 18, 23, 28, 33, and 38. So we want to find the sum with our calculator. So the way we do that is we're going to choose alpha F2. And if you look at number 2 here, you see that that is going to do the sum for me. So right here, this is where, you see the blinking cursor? This is where your variable goes. We're just going to choose x for our variable. Typically in a problem, you'll see this as n. It'll typically be n, but we're just going to use x since that's the default on our calculator. And this is asking me, what term do you want to start with? Where the cursor is blinking. Well, I want to start with the first term. And what term do I want to end with? I want to add them all up, so I want to end with the 8th term. Right? So I want to put, I'm going from 1 to 8. There are 8 terms in there. And what I have to put here, guys, is the rule for a sub n that we came up with a few minutes ago. So if you look back at your paper, that was 5n minus 2. So if we put our rule 5, and of course we're using x, remember, 5x minus 2, and then come outside of these parentheses, and we hit enter, boom, there is our number 164, which we got here just before by using our formula. All right, so that's very nice indeed that our calculator will do that for us. All right, let's look here for a second. If you have a TI-83, or perhaps your 84 does not have an upgraded operating system, what you're going to need to do to find the sum of these sequences is you're going to have to go to list. If you look right above your stat button, you have list, so you're going to go second, stat, and then you're going to come all the way over here to math, and you see sum is number 5, so we're going to choose 5. And then what do we want the sum of? We want the sum of a sequence. So once again, we have to go second, stat, and then we come over to ops, and we choose sequence, which is number 5. And our expression is our rule for a sub n. So we got 5x minus 2. Our variable that we're using is x. What term are we starting with? We're starting with the first term. What term are we ending with? The 8th one. What is our step? The step just means, am I skipping any term? But if I wanted the sum of every other term, let's say for instance, then my step would be 2. But I want the sum of all the terms, not skipping any. So I'm going to say my step is 1. Then I'm going to come here and paste that in. And you see what I have here. So this is an important place for anybody. If you have a calculator and when you go and find the sum of the sequence like I just did, if you don't get the list like I just had that allows you to put the expression and the variable and all that, you're going to have to enter your information just like it is here in parentheses. So in other words, if you enter sum and sequence and then you just get a set of parentheses, you're going to put the things in order inside the parentheses just like I did, and you're going to separate your entries with commas. So you see, this was the expression, this was the variable, this is the term we started with, this is the term we ended with, and this is our step. So you'll do that, separate those by commas, close your parentheses, hit enter, and you'll still get the number that we got before. All right, so there is your lesson on arithmetic series, how to add arithmetic sequences. And in our next lesson, we will do the same for geometric sequences and series.